Well, hey, ladies. Missing you today, TGIF. Yes, we're going to have to do a lesson even though I'm not there. Basically, today is going to be something you've seen, but I'm going to teach you some strategies that, one, are faster to do, and then two, down the line, just are easier to use, I think. Faster, easier, and makes sense as well. So ratios. A ratio is a comparison of two numbers by division. A ratio of x to y can be expressed in any of those ways. I don't typically use this notation, but it is used. So we're just going to first determine whether these following ratios are equivalent or not. So we ask ourselves, is this equal? Question mark. Well, I can either reduce both of the fractions if not already reduced, or I can cross multiply, right? So I can do 6 times 5, which is 30, and does that equal, we'll do it like this, does that equal 2 times 10? That's 20, and that is a hard no. It does not. So it does not equal. So we'll just continue down the line. 2 times 24 is 48. Does that equal 3 times 16? Well, yes, it does. It's 48. So yes, the ratios are equivalent. Again, this one here, they are equivalent. I can reduce this to 1/6. But if I were to cross multiply, I'd get 54 is equal to 54. So yes, again. And then finally, this one, you could just reduce both of them. I believe it'd be 8/9, right? This is equal to 8/9, and this is equal to 8/9. So you see, both ways you can do it. It doesn't matter which way, as long as you can identify that the ratios are equivalent. Also, proportions are equivalent. So solving proportions, we use the cross product, just like we did there. We crossed, multiplied what it was across, kind of across from each other, right? If we need to, we'll round to the hundredths, okay? So if we start with this one, pretty straightforward. I'm going to do 9 times x, which is 9x, and that's going to equal 10 times 8, which is 80. And then I should be a master at solving these one-steppers. So x is equal to, it looks like it's just 80 over 9, but it says round to the nearest hundredth. So 80 divided by 9 is 8.89. Okay, either one would work. On formative, I have, I tell you where to round if needed. All right, so how about this guy? I need a cross. I usually always start with the top left and the bottom right. That's 8 times 3, which is 24. That equals 1 times v plus 8. There's no need to put the 1 outside of the parentheses. I'm doing it just to show that we would typically have to multiply whatever that is on the outside to everything inside of the parentheses. I just dropped the parentheses there, and then I'm going to subtract the 8. So v is equal to 16. All right, moving on. Some of you might have already. Again, we're going to cross multiply here. X times 9 is 9x, and then that is equal to 10 times x plus 5. Okay, you can have x plus 5 times 10, but I just think it's easier to put the constant out in front. So we're going to distribute and then combine like terms. So it looks like I'll subtract the 10x. Negative x is equal to 5. And then that negative x, we need to divide out a negative 1 to get rid of that negative. So x is equal to -5. Not so bad. You've all seen that before. I believe probably in 6th grade, maybe, or 7th. Yes? Okay, so the ratio of two measurements having different units of measure is called a rate. You know, kind of like 85 miles per hour, right? We do write it like this, but this is just talking about two different units is considered a rate, right? And the rate is miles per hour or cups per minute. Whatever that is a rate, and it's because it's a ratio of two measurements. A rate that is called a scale, it's to make a scale model, so something smaller to something larger, or vice versa. Typically, it's a scale on a map. So let's do some word problems using a proportion. I don't have many directions here because we're just kind of going straight into setting up a proportion. I'm not as picky about assigning variables for this, but I will just because it's staying consistent. In the past 2 years, a realtor has opened 232 stores. If the rate growth remains constant, how many stores will the retailer open in the next 3 years? Okay, so X is going to be number of stores. So we have a rate, right? It says right here, for 2 years, it opened 232 stores. So essentially, how many stores per, and then how many years? That's going to be our first proportion, is the given information that they gave us, right? So 232, and we know that that's stores, over 2 years. Okay, so that was given, and now we have an unknown. It says number of stores, and yeah, that's after 3 years. Well, if we want to know if X is stores, that's got to go across from stores in the numerator. And then in the denominator, it says years, and it says, well, how many stores in the next 3 years? So, and then we multiply that. So you see, we don't know X stores for 3 years. Okay, we go ahead and solve that. We cross multiply. 232 times 3 is 696. And then we have is equal to 2 times X, and then divide by 2. 348. And that's 348 stores. So make sure you're labeling informative. I only have the answer just like that, informative. Okay? Really not so bad. And I'm sure this is all ringing a bell to most of you. All right, so how about this modeled airplane? Well, the scale is 5 centimeters equal to 2 meters on the real plane, right? If the model's wingspan is 28.5 centimeters, what's the actual plane's wingspan? Okay, so we can do like model over actual, or, you know, whatever you want to put. X is definitely actual wingspan. So you see that I'm not technically picky about that variable there, but so the model, it gives us some information here. A model airplane is 5 centimeters equals 2 meters. So the model's 5 centimeters and the actual is 2 meters. And then we set it equal to, we don't know the actual wingspan, so that's X. And then it says that the model's wingspan here is 28.5. Okay? And we'll cross multiply. So we got 5 times x, which is 5x. And then 2 times 28.5 is 57. And then I divide out the 5. And it's going to be 10, 11.2, 11.4. Yeah, 11.4. And that would be meters, right? Because we're talking about the actual plane. All right. Let's keep moving here. Here are actual ratios that they're giving us. And I have to figure out some other information. So it says 2 out of 5 students in the 9th grade have braces. So 2 out of 5. Okay, that's 2 out of 5. And if we also know that this is part over whole, right? There are 325 students in the 9th grade. How many have braces? So 2 out of 5 do have braces. Okay, so if they tell us that there are 325 students, that's the whole, right? I don't know how many have braces. So that's basically number who have braces. And I have this over here. Oops. I have this over here, but I set this up. I set this x over 325 because it says if there are 320 students in the 9th grade. So that's the whole, as I said. And then the part is how many would have braces. So whole over part. So 2 out of 5 people have braces. So how many out of 325 have braces? We cross multiply. 5x is equal to 650. And then divide by 5. X is equal to 130. That's 130 students. Okay, so it's very important to understand part and whole. Sometimes it's not always part and whole together. It could be part and part, meaning girls and boys, right? Which I think we'll be talking about. I may have added one, I may have not. I thought I did. That's all right. Let's keep moving on. A lot of you have used this proportion before. I say, yes, set it up and solve it using that proportion. I'm okay with that. But I'm going to show you some quicker ways. And I suggest that you kind of learn these ways because it will help you on state tests to get through things quicker. So I will do both. Is over of equals percent over 100. We talked about this in chapter 0. Okay, and that's why I said if you have another method, you can use it. I think another equation is you have whole times percent is equal to part. I've seen that before. So we might use that. If we use this, round to the nearest percent or tenths place as needed. What is 42% of 50.9? So again, a lot of you will go straight into it and say, well, what is, I don't know the is, of is equal to 42 over 100. Well, anytime we need to find is, I need to find the part. So that's kind of like what this is. What is the whole? Well, the whole is 50.9 times the percent as a decimal, 0.42, is going to equal our part. So if I were to rewrite this equation right here, I could write this as of times percent equals is. Okay, kind of makes some sense. And we can, solve it or plug in certain things and solve for the other maybe. All right, so this is just, this step here, like this guy is just an extra step where this is just like one step, right? So what do we get there? 50.9 times 0.42. So it looks like we're going to have nearest tenths, 21.4 is my number. That's 42% of 50.9. So now we have 1 is 32% of what? So let me just go ahead and use this then. Of what? So I don't know my of, so that means I'm going to put an X in for of. 32%, that's 0.32, and then that's equal to 1 is, so that's equal to 1. And then look, to solve for X, what am I going to do? Just divide by that 0.32. And it looks like I have 3.1. Okay. It's 3.125 if I really wanted to write it out. I just tenths place. But this is nice because it was terminating. It was a terminating decimal. Okay, so you see, I think that that's a little bit easier, which I believe some of you mentioned that, oh, I know an equation instead of using the proportion. Totally fine. 92 is what percent of 384? So we don't know the percent, but again, I can use of times the percent is equal to is, or whole times percent is equal to part. So it says 92 is, so that goes here. I don't know my percent, and then my of is 384. And if I divide that out, and you might already know that you can just divide it, find the decimal, and it looks like I'm going to have 0.2396. And if I translate that to a nearest percent, that's 23.96, but I'm going to round that to 24%. So 92 is 24% of 384. All right. Here it's 40% of 1 is what? So I don't know my is. Again, I just think the of times the percent is equal to is a lot easier. So I don't know my is, my percent as a decimal, and then my of 1. Well, that's pretty easy. X is just equal to X is equal to 0.4. 0.4. Okay? Not so bad. So now we're going to be talking about percentage of change here, where we have like a new amount or an old amount and need to find if there's a percent increase or decrease. All right? Okay. So, percent of change in the ratio of the change in amount to the original amount. So I said, original or new amount and old amount. We can use the nice formula, new minus old over old. So new value minus the old original value is divided by old. If it is positive, the result, it's going to come out as a decimal, then it's a increase. If it is a negative decimal, then it is a decrease. So we're just going to go right into it. Determine if it's a percent increase or decrease. Round to the nearest percent as needed. Okay. Determine the actual percent. Obviously, if we're going from something larger to something small, it's going to be a decrease. Let's go ahead and, put it in the equation. New, or formula, minus old over old equals some percent. And it looks like it's going to be a percent increase. So it's going to be a percent decrease. So it's going to be a negative decimal. So the new amount is 30 minus the old amount is 66 divided by the old amount, which is 66. In your calculator, you'll need to put parentheses around that or use the fraction. And what does that equal? 30 minus 66 divided by 66. I get negative 0.5454 repeating, basically, right? So that, if I move the decimal 2 spots to the right, that is 50, and I'm going to round it, 55% decrease. So, informative tonight, I have it. 55% space decrease. Okay? All right, how about the next one? From 110 to 172. So it is an increase. We can label this as this is the old and this is the new. So our new minus old over old. Okay, and it looks like I'm getting a positive 0.4454. So if I were to round that to the nearest percent, remember 2 spots, so that looks like it's going to be 45% increase. All right. This last one here. So that really isn't that bad. It's just knowing that formula. I think it kind of has a ring, new minus old over old. So this is our new. This is our old. New minus old over old. Looks like I'm going to get a negative 0.4744. I didn't mean to have these so close together. 55, 45. And again, I don't put the negative in there. That just tells me that it's a decrease. And what percent? That's going to be a 47% decrease. Okay, so as I said, this isn't so bad. You've probably seen this before. Unfortunately, we now have some word problems that we're going to do using proportions. Maybe using the percent increase decrease. Maybe just using a method that I'm just going to, hopefully you can conceptualize it and understand what I'm saying. And we'll talk more in class on Tuesday about these problems and the homework as well, okay? For the following word problems, use a proportion to solve if you have to, but if you know a different method, use it. Just make sure you're showing me your computations, and I'll show you what I mean. There are simpler methods to compute these values. So Marta is purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. If the tax rate is 7.25% of the total sales, what is the final cost? So some of you might say, okay, I know that what is 7.25 of this, right? That's kind of what we want to know. Okay, well, I can figure that out. by doing 28.62 times 0.0725 is equal to something, and then take that something and add it back onto 2862, right? Let me just compute that. Okay, so this was 2.07495 plus 28.62. So our final answer, our final cost is $30.69. Okay, so that was one way to do it. Some of you might have been like, okay, well, what is 7.25% of 28.62? Same kind of idea as the green stuff, just using a proportion. I'm still going to have to find whatever that percentage is, and then I'm going to have to add it on to the original, right? Well, Ms. Coates likes to do it in one step. If I'm going to be paying for this 28.62, I'm paying 100%, right? I have to pay for that. And then I'm adding on 7.25%. So what is 100 plus 7.25%? Is 107.25%, right? Well, what is that as a decimal? That is, that is 1.0725. I'm going to be honest with you, I normally don't show that. I just say, well, if we're paying for 100%, that's obviously 1. And then we're adding on the sales tax, which is 7.25. So this would be my decimal, and all I have to do is multiply these out. And obviously I'm going to use a calculator and not actually multiply that out. So 28.62 times 1.0725, and look at my answer, 30.69. Okay, one step instead of possibly 3 steps with the stuff we did up here. All right, that is the sort of ideas I'm wanting you to start conceptualizing and understanding, because it will save you time down the line. So let's try the next one. Benji is shopping for a car. The cost of a new car is $15,500. This is 25% greater than the cost of the used car. What is the cost of the used car? Ooh, okay, so this can be done in several ways. Some of you might say, well, 25% more. So then that's kind of just leaving out 75%, right? So some of you might just multiply 15,500 by 75%, and that's going to give you maybe the value. I don't know. But what I'm going to say is, and I didn't assign a variable up there, did I? Shame on me. X is going to be the cost of the used car. So it says that the used car, or the new car, this is 25% greater than the cost of the used car. Well, in the previous problem, if it's 25% greater than, I'm already going to have 100% value of the car, right? Well, if it's 25% more of it, then that would be 1.25, right? So 1.25 times the used car should give me 15,500, right? Because it's an increase. It's basically 25 greater than. Okay, I'm going to show another way. This would have been 1.25x, because I'm saying 125% of the used car price is going to be 15,500. So 15,500 divided by 1.25 is going to give us x is equal to 12,400. Okay? So that's a little bit tough to kind of conceptualize, or maybe you did get it. But we can also use new minus old over old, right? So it says 25% greater. So that means that from my used car, which we'll say is the original, my new price is 25% more. So it's a 25% increase, right? So if I have, I'm going to space this out, new minus old. I'm forgetting that you guys are looking at this on your laptop, so you can actually see way smaller, right? So if I have new minus old over old, and I said that it was a percent increase of 25%, okay? Well, we can do something about that. So I don't know my used car, right? But I know my new car. So that's, I haven't done it this way, but it should work this way. Minus the old car, which is the used, and then overused. Yeah, it does work out this way. So how would I solve this equation here? So you see new minus old over old equals a 25% increase. That's where we get that 0.25. So my first step here is going to be to multiply both sides by x. And you don't need the commas, by the way. And then look, plus x, plus x. So just like I showed you in the first step, that 125% of my used car is going to give me 15,000. And sure enough, that's going to be 12,400. So if you noticed, we could not do 75% of 1,500 or 15,500. Okay? I know that seems tough, but you ladies, I think it's really good if you start understanding kind of the go-arounds of these percentage problems. Okay, let's talk about this one. After a 22% discount, a pair of jeans cost $111.75. What was the original cost of the jeans to the nearest cent? Okay. Okay, so I'm gonna do it two separate ways. I'm gonna do it talking about, so we're gonna say X is the original cost. Okay, and it says 22% discount. So this is where I'm going to throw some of you maybe for a loop. If it's a 22% discount, what am I paying for? What percentage? I'm paying for, not 88%, 78%. Right? So, 78% of my original cost is going to be this sales price, right? Because I'm taking 22% off the 100%. That's where I got the 78 from. I did 100 minus 22. That's where I got the 78. So I know that 78% of my original cost is going to equal this discounted price. So there, it's essentially a one-stepper. And then I'm going to show you if okay, I can't enter anything into a calculator. Divided by 0.78. Okay, I thought I did this nicely with nice numbers. 143.27 is what I got. Let's do it another way, and we'll see if that works. After a 22% discount, yes, okay. So 22 discount, that's a percent decrease, right? We don't know the original price. That's what we were saying. That's what X is, right? But we know this new price. This is our newbies. So new, let me draw a line here. New minus old over old equals a 22% decrease. So let's see how this goes. The new price is $111.75 minus my old over my old equals that negative 22%, because that was a discount, a decrease. Okay? First step there would be to multiply both sides by X. Right? Those X's cancel. I'm left with 111.75 minus X is equal to negative 0.22X. I then add the X to both sides. And that's going to be 78.78. I have a, yeah, 0.78, okay. And then divide, which, if you notice, that's the same thing that we had up here. Okay? So X is equal to, a pair of jeans cost about $143.27. Okay? So you've done problems before that involved discounts and percentages and this and the other, but they may have not been so tough. Maybe. I don't know. So we got one last one here. Shopping for a video game system. But these stores, they got these markups. Markups are basically, this is the cost of that the store buys it at, and then they mark it up 1%. So not only are they charging 100%, but they're adding on 1% to sell it at. So at which store should you buy your gaming system? I know your outline is not like mine, but if you can write to the side, basically what our new price is going to be, right? We can say it's the selling price. What is the selling price? Okay, and how can I do that? Easily. If it's a 40% markup, I just said out loud, well, I said everything out loud, that I'm paying 100% and then I'm adding on 40% markup. So I'm going to do 162 times 1.4, and that's going to give me 200, the selling price here is 226.8. I'm going to do the same thing. I'm going to, Juju Jammin Gaming. That's $226.80. And then $150 for Graffiti Game Shop. 155 times 1.3, because not only are they going to sell it for the 100% of what they bought it for, but they're going to add 30%. And that's going to be 201.5 or 50 cents. And then 160 times for a markup, we multiply it by 1.25. And that's 200. 200 even. So at which store are we going to buy it from? Obviously, Game Hop Shop. It's the cheapest there. If Juju Jammin has a weekend sale And which discount must they offer you? They offer for you to buy the system there. Okay, so basically we want it to be $200, right? Because the lowest one is 200. So I want to know, there's a couple ways I can do this. I want to know how much do I have to take off of 226.80 to be 200, right? So, or, so take off. So let's say my mind's kind of like going in a couple different ways because I don't know which way I want to go. We're going to set X is equal to discount price. We could just do new minus old over old probably. Let's see. If my new minus my old price over my old, may not have been as hard as I was thinking. Well, not hard, but I was thinking more complex here. Yeah, that worked. It's negative 0.118, which is negative 12%, so we need to have a discounted price of 12%. We wouldn't say negative, right? So that one wasn't so bad. I was thinking about it as 226.80 times a percent is equal to 200, but you'll end up getting the percent that you're going to pay for. Like you're going to pay. So like you're paying 200. So like really you're going to pay 88%. That's what you'll get if you do this orange here. If I subtracted, I could have subtracted 200 from the 226.80, and I want to know what percent of 226 is the 26.80, if that makes any sense too. You see, there's not infinite ways that you can do it, but there's a lot of different ways, and I'm willing to accept any way as long as you're showing me your work, okay? I need to see computations. You can't just give me a number. I need to see mathematically how did you find that number. Okay, I know that was a lot, and then with me not there, I know it's not as exciting, but you should have homework. It's also on formative, and you'll submit your answers on formative. Do not stress over the homework if you don't get it or if it's marking it wrong. We will talk about it on Tuesday, okay? TGIF, have a good rest of your day.